This is a quick tutorial on what to do for this last project. What you have to do is, I'm basically giving you the introduction, but also as introduction I want you to find at least 3 newspaper articles, one of which I'm already giving you. The other two have to be similar to this one. Click on the link here, please. Click on this link as well. Try to see what it is all about. It is basically about the difficulties of explaining exponential growth to people. Try to find 2 more that more or less talk about this problem in more or less the same way as this one is doing. And for the second part, you have to give me something. You have to analyze some data for your corresponding country. Let's see how to do that. So this is the data that you have. I'm gonna put it as this is it. You have it like this. All the countries with all the reported cases every day since the pandemic started. Now, you need just one country for which I'm gonna create a filter because I don't want to see all the data. So I'm gonna select this column, go to data, create a filter, and this is the filter. If you click on the filter, you're gonna see all the countries over there. Clear it and select just the one you're interested in. I'm gonna be working with Spain. And when you click OK, you only see the data for the country you selected. Now, we're interested in the number of cases, in seeing if they grow exponentially or not. You have data since the last day of the past year, but we're interested in when the cases kind of started to be consistent. Like you have 1 here, you have 4 the next day, 5 the next day, 13 the day after, and so on. So I'm gonna just pick this data, select all of it, and I'm gonna paste it on a new sheet. Okay, so this is it. Now, this column is not correctly labeled as years because this is how it changed from day to day, and this is day 1, this is day 2, this is day 3. You have to rename all of these things, but you just have to write like 3 cells. You can select them, then click on here and let the spreadsheet do the autofill. There you have it. Now these ones are daily cases, and we're interested in the total number of cases. That's how the tally goes up. So we're going to start here, and then we have to add all of the other ones. So I'm going to use this function sum, the starting one, plus the new generated case at day number 2. And again, I just have to copy this formula up, and it autofills it. So if you were to graph this column against this column, you go to insert, chart, and it gives you something like this. Sometimes Excel chooses to give you something like this as a line. I'd rather have it presented as just a scatter plot. So go here, scatter chart. This is it now. I need you to give me an exponential model, so you need to find an equation, an exponential equation that fits the best this data. The spreadsheet on Google can do that for you. You just have to go here, customize, series, and the last option, check this box, trend line, and it's going to give you that. By default, it's going to give you a line for a linear relationship, but we know that this is most related to an exponential growth, so we're going to choose the exponential instead. This is it. These options control the color of that line, the opacity, how thick it is. None of these are important. These two last options are the important ones. I want you to see the equation, so on label choose use equation. Here it is, where this is the theoretical starting number and this is related to the rate of growth, and then show R squared. This is the coefficient for the regression, and the closer this one is to 1, the best the fit is to the data, the best this actually describes what's going on. So this one is pretty close to 1. It's a good fit. If you see closer here, these two last points are kind of not following the trend. That might be because the government has already applied, has put in place some restrictions. These restrictions to the mobility are helping to contain the spread of the virus. So one question is, what happens before the government takes any action? For instance, after just 20 days. Well, you can see that as well. Let's just choose the data for the first 20 days. And we can do the same. Here's our graph. And I'm going to do exactly the same thing. So this is it. If you take just the case for 20 days, this one, remember that this is the graph of the total cases according to each day as they increase every day. For all the days that we have right now, 35 days, and this is just up to day 20. Up to day number 20, the R squared, the exponential function, is almost perfect, fits almost perfectly to the data. This means that the growth is almost exponential, like almost perfectly exponential at the beginning of the pandemic. And also, if you notice this K factor, which is related to the rate of growth, is bigger if you take only the analysis for the first 20 days. It will mean that it's actually rising faster, it's increasing faster, as we would expect, because after some days, people and government take actions to contain the spread of virus, as I said. So this is only what we would expect for this. And what I want you to do is to try to analyze something like this. What happens in the total cases versus days for all the days that we have data available for, and then tell me something in between. What happens at day 10, what happens at day 15, 20, some period like that.